Okay, our first speaker is Larry Roberts, and it's my great pleasure to introduce Larry. And I've got 3 pages of bio here that I'm not going to read the whole thing, but I will tell you that, first of all, Larry's a great guy, and he can answer any question you have on or off topic. Just want to get that out there. Larry has a BS in chemistry from the University of Massachusetts in Amherst. And then he has a master's from Northeastern University, also in chemistry. Larry started with W.R. Grace in 1974. I was 13.
66.
It's not on here, Larry.
You didn't read that well.
Jeez. Okay, in 66, I was 5, so it's even longer back. So. But Larry has done a lot of different jobs with W.R. Grace and retired in 2006, worked for CTL for a bit, and then has been consulting since 2009. Larry is an ASTM fellow. He has a lot of other accolades that I could say here, but I will tell you that, again, just the most knowledgeable person that I know in the industry. And Larry is going to talk about early development of water reducers in the U.S., an example of innovation, competition, and cooperation. Larry?
Oh, shucks. Thank you, Terry. Good morning, everybody. Thank you for getting out of bed early. I know many of you may have inverse jet lag. Anyway, you traveled a bit to get here, and I appreciate you getting up early in the morning to hear me talk. Why am I here in this session about innovation and sustainability? Well, the reason is 3 or 4-fold. Actually, as it turns out, to see a lot of old friends. Hi, everybody. Secondly, it is unfortunate that in the recent past, a really excellent book has come out on admixtures by Flatt and Aitsin, that unfortunately the discussion of how water reducers were developed got somewhat, extremely jumbled. And that brings up the third reason. The third reason I'm here is that I happen to be, I am sure, the only person alive who worked in the development of water reducers extensively and knew the very first person to do it. And so I felt it a responsibility to correct the incorrect discussion in that book and put on the record exactly how water reducers were developed. Because what actually occurred in the development of water reducers is a wonderful example of, as it says here, innovation, competition, and cooperation. So I'm going to hit the forward button. Here we go. So here I am. I am on the left, and this gentleman is on the right. I look, I think, a little bit like the fellow in the Geico commercials, a caveman. I clearly had darker hair than I do now, but I think I'm recognizable as me. This gentleman you don't know. His name is Maynard Renner. What happened? Well, I was at the wedding of a very good friend in 1985, and I sat down at the reception table out in the lawn, and this older gentleman sat next to me purely by chance. And he said, as often happens in those situations, "What do you do for a living?" And I said, "Well, I'm a chemist, and I work for this company called W.R. Grace down in Cambridge, and I'm working on chemicals that go into concrete." And he says, "Oh, really?" And I said, "Yes, we have these chemicals called superplasticizers, or sometimes called water reducers, that go into the concrete and make it have better workability, more fluid, depending on how you want to look at it." And he said, "Oh, really?" And I said, how do you do that? And I said, "Well, we have this chemical. It's called naphthalene sulfonate formaldehyde condensate. You probably never heard of that chemical, but we use that, and I'm developing superplasticizers based on it." And he said to me, "Well, let me tell you a story, Sonny." So I'm going to tell you Maynard's story. Maynard was working at the Dewey Naomi Chemical Company in Cambridge. That was the company that W.R. Grace bought out in the 1950s. And it had a bunch of products, one of which was can sealing compounds. A major product line that they had was can sealing compounds, and they became the world-dominating supplier of those materials. Maynard was working on developing better can sealing compounds and also working on the area of artificial rubber for those sorts of applications. Well, one day he's working in the laboratory and he gets a call from the main office, and they say, please come to the conference room, you're needed. So Maynard puts down what he's working on, goes to the conference room, and when he gets there, there's several people he does not know, he finds out later are from the Cabot Corporation, and he is requested to take the sample of carbon black that the Cabot people brought and see whether or not it would go into a solution of the naphthalene sulfonate formaldehyde condensate that he was using in the development of can sealing compounds. And the reason for this was that the Commonwealth of Massachusetts wanted to make a center lane of a highway black. Back in the day, when I was growing up, we called them suicide highways. You have one lane this way, one lane that way, and one in the middle to fight over. And so they wanted to make it black so that you could tell that it was different from the other lanes. But when they put carbon black into the concrete, it came out looking all splotchy and like an Appaloosa horse. So not very helpful to get the message across to the drivers. So Maynard took the stuff, went back to the laboratory, mixed it up in a little bit of naphthalene sulfonate, looked exactly like India ink, brought it back to the conference room in a matter of a few minutes, and said, yeah, it seems to work fine. So he was then told that a bigger sample of carbon black would be coming from the Cabot Corporation, and that when it arrived, would he please go to the store, get some cement and sand, and see if it makes a dark mortar, which he did, and it did. So then they went to the field test level, and here's all that. Lo and behold, here's a road, Route 1 in Avon, Massachusetts, that was placed with this material. Now I'm going to try the laser pointer. Where is the laser pointer on here, Terry? Yeah, it's okay. I can just explain. So you can see the little arrow there. So this is the center highway, and you can see this was taken shortly after it was placed. Did a good job of making a black highway. Well, one of the things that is really remarkable is that very shortly thereafter, action was taken. Now, I have to tell you something about Dewey and Elmy. Bradley Dewey and Charles Elmy were friends. I believe they first met at Harvard. They both were rubber chemists. They both had gone to Harvard and MIT, and they were people who were used to getting things done now, not 5 minutes from now. So during World War I, they had worked on the production of gas masks for protection of the Army troops in the fields in Flanders, if you will, in World War I. Bradley Dewey was the head of that, and actually in World War II, he became Roosevelt's rubber czar. So he's a pretty serious individual. What they did, which is pretty remarkable, this is a list of the patents, and we're going to talk about some of these patents and how what Maynard told me interrelates with these. But what's really remarkable is that up here, this is where the highway was placed, and you can see the highway. This is the time. We got a timeline down here. Here's the timeline, December 30, 1931. So here's where it was placed, sometime in 1931. Before 1932, the company had hired Henry L. Kennedy. That name may ring a bell. Henry L. Kennedy Award of ACI. He's past president of ACI, became a strong person in the industry. And he was an architect in Boston, and they hired him before getting any patents, before really understanding what the business was. And the reason for that is that when they placed that highway, they did the right thing. They took good samples of everything. They tested them. They found that the concrete was nice and black, like they wanted it to be, but more than that, it was stronger than the other concrete. Now, since it was swimming in a bath of naphthalene sulfonate, we're not particularly surprised about this, but they had intended to disperse the carbon black. They realized immediately that they had dispersed the cement. And in dispersing the cement had lowered the water demand of the concrete, thereby making it stronger. So, thinking that maybe people would like concrete a little bit stronger, they said, let's create a business. And before they even had the first patent written, they hired a serious guy to run the business. So, a lesson here is when you've got something, act on it and don't be shy about it. So, Maynard went on with his story to explain that they had developed the product, it worked, but as they were working on it more and looking at it as a business, they found that the cost of the product, relative to its effectiveness, back in the 1930s, of course, naphthalene sulfonate was made using a fully manual process. You had to stand there and watch the temperature dials and all that sort of stuff, and it wasn't automated, and it was hard to do. And I can tell you from my own experience in working on naphthalene sulfonate, to get the best naphthalene sulfonate for use in cement-based materials, you have to really push the reaction, and it was difficult to do back then. So they found, and this is what Maynard explained, they found that lignosulfonate worked quite well as well. And so they decided, okay, we'll switch to lignosulfonate. They also understood that lignosulfonate tends to give some retardation, and for some reason, they decided to look at the ethanolamine series as something that would help in improving the strength and perhaps overcoming some of the retardation from the lignins. Unfortunately, after this wedding was over, I was obviously excited to talk with Maynard and wanted to follow up with him, but he died fairly soon afterward, and I never got back to him to understand how it was they came up in a year with the idea of using ethanolamines to overcome lignin retardation. Anyway, after the wedding, and after I had all this information, I thought it was a great story, but I just sort of filed it away. A few years later, my group was developing chemicals based on a combination of naphthalene sulfonate and lignin. And of course, to do the right thing, you've got to go back and do a patent search to make sure you're not infringing anybody. I did that search, and I came up with a very interesting patent, which you'll see at the end here, the basis of which made me go back down and dive into all of the patent literature around this. And what I came up with is, I think, a very interesting story. So, you'll note in this that there are several patents that are filed very early. Since I started this back in my Grace days, everything that was Dewey and Almy is green. Everything that was Master Builders is blue. And the gray one here is pertaining just to cement, so it doesn't have a color. But here are the Dewey and Almy patents, here are the Master Builders patents. But what Maynard told me was that as they got working on this lignin thing, they found, and started filing patents, they found they were getting a patent interference from this little company in Cleveland called Master Builders. And therefore, they had to figure out what to do. Many times, and in more recent times, likely there would be a great patent fight, and the lawyers would get a whole bunch of money, and somebody would win and somebody would lose. They made a different decision. They looked at the technologies that both companies had, and they worked it out so that Dewey and Almy, which had no admixture business at all at that time, took the application of this technology in the cement area. Master Builders took the technology application in the concrete area. I presume somewhere in there were cross-licensing, but I don't have evidence of that because when I went back to the Grace Patent Department, having discovered all this, those records had been lost. There was a flood in Cambridge, and a lot of company records were lost back many years before I was there. So they couldn't help me as to exactly how this resolution came about, but I think I can tell you from the stories that we have from the patents themselves. So let's go into some of the key patents. What I want to do in going over these patents is look at the actual patents and show you where critical decisions were made. So here is the first patent, filed in 32, but only issued in 38. These are all I'm discussing these in terms of the filing date, not the issuance date. And this patent was filed way back in 1932. And over here, you can see it says, the method of increasing the plasticity of a cement concrete mix which consists of increasing the number of discrete particles available by hydration by dispersing the individual cement particles throughout the aqueous mass by the addition of a cement dispersing agent. And that's the critical thing about this patent. It doesn't say what dispersing agent. Later on, and I think it's, in claim 14, it begins to mention naphthalene sulfonate formaldehyde condensate. But the primary claim is not for naphthalene sulfonate. The primary claim is any dispersing agent. And that is the critical part of how they wrote this patent. They patented the concept of putting a dispersant into cement, or cement, which could be mortar or concrete, and thereby lowering the water-cement ratio and improving the workability. Moreover, they were smart enough in 1932, where are we here? Dang it. Well, down the bottom, where it says, by the addition of a heat-resistant cement dispersing agent. The heat resistance is an important thing. That means they were already, in 1932, thinking about putting it onto cement production, where heat resistance is an obvious important thing. And then they go on and talk about the combination of hydraulic cement and a water-soluble cement dispersant. They covered water-soluble. And finally, like I said, in number 14, they call it naphthalene sulfonate. So what we would call today a very fundamental patent. And that's the genesis, I think, of this cooperation, competition and cooperation that ended up. The next one is my acquaintance, Maynard Renner, actually got his name on the patent, which was filed in 34. But Henry Kennedy is also on this patent. And this is the process of preparation of concrete, mixing hydraulic cement with an ethanolamine, a triethanolamine. And then later on it goes to claim other ethanolamines and composition of matter of a dry hydraulic cement with triethanolamine on it, et cetera, et cetera, et cetera. So he's got process. So they're tying up the use of ethanolamines on anywhere cement shows up. And then later, in 35, a fellow by the name of Mark, assigning again to Dewey and Elmy, begins to look at this question of lignin. They must have seen I'll show you later the filing for master builders. They must have seen this lignin filing. They must have understood something about it. And he files, darn it, he files, where? Maybe I can use this. No, yeah, it doesn't work either. Maybe you can see it. You can see it, okay? Okay. Up here, I've discovered that certain agents not mentioned by Dr. Tucker, refers back to that, even though that patent hasn't issued, it's in process, it hasn't issued yet, possess an even more marked degree the properties of dispersing cement particles and producing high slumping concrete. And then these are commercially pure water-soluble derivatives of lignin, not plain waste sulfite liquor, but derivatives of lignin. And then in his claims, he says a soluble derivative of lignin which has been separated by chemical treatment from other constituents. He doesn't say what chemical treatment. This covers any chemical treatment. And that's a lesson in how you write patents. Later on, he talks about exactly how to do it, examples. He basically claims from the examples. But here he makes the overarching claim of any lignin purified by a chemical means. And then the most interesting thing that really made me smile. Here is a patent in 1940, a little bit later than the other ones, which is from a guy by the name of Edward Scripture. And that may not mean anything to any of you, but the bells really went off in my head because I knew who Edward Scripture was. Edward Scripture was the primary researcher for master builders. He had been filing patents, which you'll see in a minute, for, at this point, 6 years for master builders. And here he is assigning a patent to Dewey and Elmy. What's going on? Clearly, to my mind, this was a trade-off. This was something received in trade in the negotiations between the two companies. So what it says, where are you? There you are. Okay. A cement composition comprising a mixture of cement and cellulose waste liquor modified by precipitation of sulfite ions therefrom. Obviously, a chemical process. So this falls under the Mark patent such that an amount has substantially no alkaline earth compound capable of accelerating the concrete remains after reaction. So only a small amount. Well, alkaline earth means calcium, and the product they were using to do this is calcium chloride. So, and then he claims plasticizing and indurating, which is a word I guess that means to make more durable. Master builders love that term. But it's not assigned to both companies. It's assigned to Dewey and Elmy. So when I saw this, I said, there's really something going on here. Let's go back and understand the master builders patents a little better. So let's go back here. We're seeing the master builders are starting to file about 2 years after the Dewey and Elmy filings. And the key one is this first one. Filed in 1934, and it's a mortar or cement mix containing the ingredients of waste sulfite liquor in substantially the proportion provided by the addition of a mix of them 1/2 pint to 1.5 pints of waste sulfite liquor per sack of cement. So for those of you who study the process of patents, notice how the primary patent is very specific. The primary claim is very specific. What does that mean? That means that any subsidiary claim is also that specific. It's not wide open. It's very specific. But so they claimed waste sulfite liquor as a particular material. So Tucker had not claimed waste sulfite liquor. You can certainly get a patent on waste sulfite liquor as a good dispersant, even though somebody else had claimed a dispersing agent. But that patent is still subsidiary to the other one. Also, clearly thinking about this, the dry cement having material increased workability was also claimed. So they were thinking about putting it into cement as well. And they used the term, in the primary claims, they always say, which render the cement particles mutually repellent in aqueous medium. Only by claim 6 do they actually use the word disperse, whereas the Tucker word disperse was up front. Okay? So, here's, this one, actually, I'm not going to bother with it. All it does is it extends it to pozzolans. Then the critical patent that for some reason Scripture did not assign to MB, it was just to himself. Clearly he assigned it later on. And this claims waste sulfite liquor and calcium chloride. Also claims the pozzolanic material. So now they're clearly claiming waste sulfite liquor and calcium chloride. And so what was going on here? Well, this is the patent that really got me into this. This is the one in 1951, again Scripture, assigned to MB, a mixture of desugarized waste sulfite liquor solids and naphthalene sulfonate. So I was free and clear in the 1980s when I was doing this. This patent had long expired, so it clearly indicated that I was free to practice. But what's remarkable here, look at what it says up in the beginning. What are believed to be the first cement dispersing agents known to the art were disclosed in U.S. patent, blah, 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 granted to George R. Tucker, December 27, 1938. That's a master builder's patent, citing the Dewey and Elmy patent as being primary. So, what have we learned from this? Here's the filings. Dewey and Elmy filed on the concept of dispersion. Master builders filed on waste sulfate liquor. Dewey and Elmy signed on ethanolamine and strength improvers. Lignin, Dewey and Elmy filed on any chemical process to improve lignin. MB filed on dispersion to enable non-hydraulic fillers and pozzolans. And then Scripture, the waste sulfate liquor and calcium chloride. Finally, Scripture assigned to Dewey and Elmy lignin with a dose of calcium chloride, too low to accelerate. So, what appears to have happened, Dewey and Elmy filed on the idea of water reduction through dispersion. Master builders filed on the waste sulfite liquor, but needed access to the dispersion patent. Dewey and Elmy filed on purified lignin. MB needed access to purified lignin. But MB did not want to give access to combinations with calcium accelerators, enough calcium chloride to actually begin to accelerate. So Dewey and Elmy was happy to live with its ethanolamine technology, but the Dewey and Elmy needed calcium lignin, so Scripture assigned the combinations where the calcium chloride concentration was low enough to accelerate to Dewey and Elmy. I presume critical patents were cross-licensed, but I don't know that. I have no record of it. And what's important is that the industry has profited by improved concrete ever since, in sustainability, in everything having to do with concrete, and how we do it. A critical point is that this cooperation led to a situation just before World War II where cement plant grinding efficiency was upped by over 25% by these things as grinding aids. At the same time, the amount of cement required to make concrete was reduced by water reducers added at the production of concrete. So just when we needed to be able to make all the concrete required to fight World War II, we had this very big help. I call that real sustainability. So what have we learned from this? Coincidence of a family relation. I forgot to tell you, Charles Elmy was the nephew of Godfrey Cabot, the head of Cabot Corporation, which is no doubt why they were there. So coincidence of a family relationship brought the question of how to disperse carbon black in concrete to just the right people. The work was quickly done, yielding the desired result. But the critical element was recognizing the other benefits. They were paying attention. And then, realizing opportunity, action was taken quickly and significantly to build a business on this. The patents were correctly written. Interferences were understood, and the resolution decided based on opportunity, not ego, I was first, no, I was first, no, I was first. It was based on the opportunity that the company saw, and they moved forward in a way that helped the industry tremendously and helped our country in the difficulties of World War II. One other interesting aside, as I said, the technology came from a company formed by two men dedicated to supporting the U.S. Army, which was helping France and Britain in World War I. This business section of that company is now owned by Saint-Gobain, which is a 350-year-old French company. Coincidence? I don't know. If there's anybody out there from the master builder's side who has access to any of this information, let's get together at Boston. I'll buy. I want to understand what Cleveland thinks of this.